দেখা যাবে তারপর।
Hello. Hello. Good morning, all of our present here. On the occasion of the auspicious Guru Purnima, today's third day FDP talk is given by Dr. Shouvik Chakraborty sir. On a short note, I first want to describe him as he is belonging to so many projects and so many auspicious things. So, for the biography of our today's resource person, Dr. Shouvik Chakraborty is an accomplished academician, researcher and educator in the field of computer science and engineering, with extensive experience in teaching, research, software development and technical education. He is currently serving as a lecturer in the Department of Computer Science and Technology at Women's Polytechnic, Chandernagore, Government of West Bengal, where he is also the in charge of machine learning and computer vision laboratory. Dr. Chakraborty has pursued his PhD in computer science and engineering from the University of Kolkata, West Bengal, where he was awarded the prestigious DST Inspire Fellowship. He obtained his MTech in Computer Science and Engineering from the University of Kolkata in 2016, securing first position and receiving the AICTE National Fellowship during his postgraduate studies. He completed his BTech in Computer Science and Engineering from Hooghly Engineering and Technology College, affiliated with the MACAUT, and in 2014. An outstanding scholar, Dr. Chakraborty has demonstrated exponential growth in academic excellence by qualifying the graduate aptitude test or GATE in 10 times, the UGC National Eligibility Test multiple times in lecturership and JRF posts, and the West Bengal State Eligibility Test, that is WBSET. His research interests encompass artificial intelligence, machine learning, soft computing, evolutionary computing, computer vision, digital image processing, biomedical analysis, pattern recognitions and optimization technique, and image encryptions. His research has significantly contributed to advancing the intelligent computing techniques and their real-world applications. Dr. Chakraborty has published and edited books, several book chapters, and numerous research papers in reputed national and international journals and conference proceedings. He has presented his research at several prestigious international and national conferences and actively contribute to the academic community as an editorial board member and reviewer for reputed international journals. He is an active member of the several renowned professional organizations like IEEE, the Computer Society of India, and IAENG, Hong Kong, the ICSE, the MRI Labs USA, etc. With the outstanding academic achievements, extensive teaching experience, and significant research contribution in the artificial intelligence and intelligent computing, Dr. Chakraborty continued to inspire students, researchers, and faculty members through his commitment and the academic excellences. On the footnote, I am welcoming you, sir, on the third day of the FDP. Now, before we start sir's sessions, I would like to call Professor Dr. Navani Bose, sir, Principal SIMT, for felicitate, sir. Welcome you, sir. I also invite Chandernagore sir, so please come and felicitate sir. Thank you, sir. So now, sir, the dais is all yours. Thank you.
And I would like to thank Professor Madam for her kind words. I must express my deepest gratitude to the Principal Sir SMIT and all the organizing committee members of this particular FDP. And thanks for inviting me and giving me opportunity to present in front of you and discuss something. Right. So my today's topic of the talk is Beyond Prediction, Multi-Objective Machine Learning for Intelligent Traffic Management. Now, I have divided my talk into basically 4 sections. So let me just discuss about my plan, today's plan, so that you can easily grab those topics that I am going to discuss. First of all, I shall give you a brief introduction to the intelligent traffic management systems and problems that are faced by people or the other stakeholders like engineers and so on in our daily lives. We shall take a lot of examples and real life incidents so that we can understand the problem better. In the second part, we have multi-objective decision making. As we all know that most of the intelligent platforms like Google Maps, Waze, all these things works on some prediction kind of logic. So I try to convince you that prediction is not sufficient because prediction may not generate always accurate results, and we shall also discuss some drawbacks of predictions and how multi-objective decision making comes into the picture. This is the second topic I want to discuss. Third thing is multi-objective decision making, how can change the intelligent traffic management systems and its future, right? And I shall also try to give some future research work so that you can start work on this particular topic from this week onwards. Okay, so this is my plan, and again I am thankful to all of you that you have given me the opportunity to stand before you and discuss a particular topic of interest. And in the second half, you shall see some hands-on on this particular topic, how these things works. This will be presented by Mr. Pradok Shen, who is a software engineer. And I shall also try to explain something in the presentation so that you can understand better the theories and you can see those theories working. Now, before going to the depth, let me go to the introduction phase first. Can you identify this particular picture? This particular picture went viral on social media a few years back. Can you identify this? Any one of you? Again, I want to request you, please interact with me throughout the session. I am not teaching here something, I want to discuss with you so that both of it can be enriched. So please interact with me, I will be glad to share some views, and if you give me some important points or knowledge. So can you please tell me, any one of you, can you please tell me what is the picture is all about? Please ma'am.
South Korea.
Yeah, South Korea.
They changed the direction of the river and make the road in 2 sides of the river.
Yeah, actually this was the restoration project of this historical stream. You are correct, it is from Seoul, South Korea. There was a 6-lane road that was demolished over 3 years, I guess, and they have demolished it to restore this particular stream, right? So the point is, can you think of the consequences? Suppose we have collapsed the Delhi Road or Durgapur Expressway nowadays, right? Today we have collapsed it. So can you think the consequences? What will be the obvious consequences of these kind of collapses? If we remove a 6-lane road from our infrastructure, yeah, it is an obvious thing that traffic congestion will occur. But interestingly, after the demolition of this particular road, it was observed that congestion situation was not worsened. In fact, in some surrounding avenues, it has been improved. It is one of the incidents. it is another famous incident or the event, you can say. This is the news from 1990. You can see the celebration of Earth Day at Washington, Manhattan. So what happened, there is a road called 42nd Street. It was completely closed due to this celebration. So again, the administrators had thought that a severe traffic congestion may occur, but it was seen that the surrounding avenues has covered that congestion and no further congestion related issues has been occurred. Now, I have given these two examples to make you understand that it is not that we are always incur congestion when we are removing or blocking something, right? Blocking some road or removing some roads from our existing infrastructure. This thing is known as Brain's paradox, B-R-A-E-S-S. Okay? So that is, this theory is called Brain's paradox. This is the exact example of Brain's paradox. However, this one is not the exact example of Brain's paradox because before removal of that particular 6-lane road, they have taken certain measures. Although the infrastructure was not developed significantly, however, they have taken certain measures so that the congestion doesn't get worsened. Right? So, this is called Brain's paradox. Okay? Up to this, I guess it is clear to all of you. This is another incident, interesting incident that happened in Leonia, New Jersey. In one fine morning, the residents of that particular city have observed that suddenly thousands of vehicles are appearing on their town streets. Why it is so? Because the maps like Google Maps, Waze, those kind of apps are redirecting or rerouting drivers from the highway to these lanes. Are you getting it? So it was happening in 2018. Okay. So please remember that year. I shall show at the end the timeline of the development of Google Maps. So this year is important. In 2018, they have redirected all cars, most of the cars from the highway to these lanes, so that drivers can reach faster and safer. Maybe. Okay. So it is another important incident in the history of navigation. I shall come to these incidents again, why this has happened and how these maps works. So don't worry, I am not going into the depth of all these incidents, it is not necessary. Urban traffic congestion, it has been reported in this particular source that 1 trillion annually lost in productivity. Also, commuters lost an average 99 hours per year stuck in traffic. So traffic management is very important. Now the smart mobility systems or the intelligent traffic management systems is using basically two kind of forecasting models. One is short-term forecasting, that is 5 to 60 minute horizons, and one long-term forecasting like hourly or maybe some weekly predictions. Right? So how do they predict? They take some historical data from the past, right? They have the traffic movement, what is the pollution level of a certain city, and they may take the number of vehicles moving in a particular intersection of road, and they try to predict. This is all about the predictions. Okay. Now, when we are trying to predict something, we have to consider a lot of aspects like travel time, congestion, accidents, road closures, tolls, fuel consumption. I guess all of you have faced this kind of situation. For example, when you are crossing the Bali Bridge, Google Maps shows you that the Nivedita Bridge, that is beside the Bali Bridge, has tolls. So you may redirect to the Bali Bridge, old Bali Bridge, right? So these are the considerations of prediction when you are trying to predict some route. Not only the shortest path is the only concern. Now, Google Map typically not showing us a static map. How does it work? I shall talk about it in some subsequent slides. So, this is called shortcut paradox. It is very obvious. You can easily understand. If everybody is sent to a shortcut, the shortcut itself becomes congested, right? So, these are the problems that are faced by the intelligent applications like Google Maps or Waze. So it is another problem. In a particular intersection, if you increase the green light, timing of the green light, then the other side of the road will be congested. Right? These are the trade-offs. So another problem is we have to give some models, or we have to design some intelligent transportation models that will work for millions of drivers, not a single one or two, right? So these are some challenges that we are facing. Now, one thing you may wonder that how does intelligent transportation systems work? That means how can they get data from the environment or roads? So that is nothing but IoT, right? We have various sensors that those are placed on the streets, like let me show you. These are some typical sensors that may be placed on streets. They can get data from the vehicles as well as streets, right? The theme of IoT is connect the unconnected, as you know, and in today's world, everything is smart and connected, right? But it is very difficult to, suppose if you want to get data from a road roller that is 20 years old, it will be very difficult to connect it to the existing IoT infrastructure, because this part this topic is of discussion in the brownfield IoT, right? This is called brownfield IoT, and it is not possible always to integrate all devices into the IoT ecosystem. However, in today's world, most of the cars and roads are smart, and these kind of sensors are placed in the streets, right? You can see in our Delhi Road or Durgapur Expressway, you have, I guess, seen that if you overspeeding, the automatically your picture will be taken, the number plate will be extracted and sent mail, or the message will be sent to your registered mobile number, right? So the problem is the problem of traffic management. Up to this, what we have seen is something about prediction, right? We want to predict, or we want to calculate the shortest path that is useful for the drivers, or they may reach to the destination easier in an easier manner. But I want to convince you that this thing is not sufficient. Okay, how? I want to give you some examples, or I want to give you some real life instances so that you can understand why it is an optimization problem. Have you ever heard the word optimization? Many of you have heard. There are so many respected professors sitting here. I can see. I know they know this topic, but many MTech students are here. I guess. Have you heard about the optimization? Anyone? What do you mean by an optimization problem?
All the audience they belong from the faculty.
Okay, yes.
Students is participating in
Okay. So can I expect that you are familiar with optimization issues? Okay, yeah, that is quite obvious. So in case of optimization problems, what we do, we try to get something that is optimal. I mean, that can be maximal or minimal, right? So in this case, what we are doing, we have to define a goal, we have to identify the constraints, and we have to find the solution. Now, why it is an optimization problem? Let me explain this particular diagram. When we are moving in a road, we have to consider all these things, isn't it? We have to maximize safety, we have to consider about the time, we have to find out the faster routes, pollution level should be lower, minimize travel times, reduce emissions, and etc. etc. So we have to consider all these things, not the shortest route itself, right? We cannot consider only the shortest route from a particular location to another location and give you that particular direction in the map, right? So traffic management is a multi-objective optimization problem, because suppose, let me give you a simple example. I shall take a lot of examples. Suppose we are in the market to purchase a car, okay? So if you pay more, you will get more comfort. This is obvious, right? There is a trade-off. So it is not possible always to optimize everything in a road, right? You cannot optimize every possible contradictions of any situation. So we cannot get any perfect answer. And what is the meaning of this perfect? I shall explain it by mathematics. Okay, so by simple mathematics. Don't worry, I'm not here to overwhelm you with some technical and mathematical jargons. So I shall explain what is the meaning of this perfection. I guess often you have seen that Google Map, suppose you are on a highway, Google Maps shows you recalculating and then redirect you in some surrounding avenues and then again put you on the highway. It is often happen in the hill areas. So why this is happening nowadays, I shall also discuss about it. So these are the trade-offs when you are trying to find the base routes. For example, you have to optimize travel time, congestion, road closures, fuel consumption, tolls and accidents. All of you have, I guess, experienced these things in real life. Now there are several machine learning models that can be deployed for the prediction purpose, like temporal models, graph neural networks, reinforcement learning, and so on. So up to this point, I have given you some real life situations, and I have tried to show some glimpse of why intelligent traffic management system is not about predictions only. Okay. We have to think about multiple dimensions of this problem, and we are trying to convert this problem as a multi-objective optimization problem. So before going to the multi-objective optimization, we have to understand what is the meaning of multi-objective decision making. Can any one of you from the audience help us or enlighten on this topic? If anything is known by you, it will be helpful. What is the meaning of multi-objective decision making?
Decision can be taken depending on multiple parameters. If someone want maybe asthma or something, patient can choose less polluted road than other shortcut or any main route. So depending on
Yeah, thank you, sir.
For an example, suppose we are using a machine learning model that has been deployed to serve some purpose, and then that model is costly. I mean, you need to pay for that model or integrating that API. At the same time, it has certain weights, which means it is trained on certain number of parameters. Right?
Yes,
Now,
that's a very common trade-off.
Yeah.
Yeah.
So there are two objectives basically. So objective number one, you will try to bring certain models which is trained on lower parameters, because not all the devices that can run that model having enough memory. So that is one trade-off, and another trade-off is the cost. So you have two objectives, and
Yes.
you need to there is a trade-off between these two objectives. Maybe
Yes.
that could be one area where
That's quite correct, sir.
It is like finding the corner of a polygon. So multi-dimensional polyhedricity, that is the space that contains the solution, and the corners of those space are the boundaries. Those are really the optimal ones. But among those, only those that is maximizing the global goal.
Yeah, thank you, sir. These are correct answers. I guess all of you, many of you have
one
the
example
idea of
actually you have
multi-objectives.
started with one example you have already given, started with the car one, and while you go for a car purchasing, you are
Yeah.
optimizing so many areas.
Yeah, exactly. So let me just show you with different examples. We shall take very named examples to understand what is the meaning of multi-objective decision making. Then we shall go for the application of multi-objective decision making in intelligent transportation system. So this is the overall situation of or the present scenario of multi-objective optimization systems. I am not going to explain this diagram now. This taxonomy is not required right now. So let me start with a fruit basket. Just forget about traffic management. So this is a basket of apples. As you can see, we have several types of apples in this basket. Right? Now, if I want to pick you the heaviest apple, then what can you do? The answer is very straightforward. I guess you have to weight all these apples one by one, and then you can pick the heaviest one. Right? So what is our objective here? We are trying to find the heaviest apple. So now when decision making comes into the picture, that particular thing, that's finding the heaviest apple, is not about decision making. Okay, we have the exact optimal answer, and we can find it by the brute force method. That is, you can pick one apple and you can weight it. Now, what do you mean by decision making? Let me show you this picture. Suppose I want to, I request you to find an apple that is heaviest and sweetest. Then what will happen? Problem is, the heaviest apple can be this one, but this one may not be the sweetest. Okay. So, if you understand this thing, I guess you are getting the essence of multi-objective decision making. Right? Okay. Suppose we are in a fruit market. Again, we have a lot of apples. Alright? Now, can you tell me which apple you are going to purchase?
Second.
Okay, maybe our
Second or third.
first, second, third, these three apples are looking good. We may purchase one of them until or unless we are giving you the price, right? So now we have the price tags. Can you tell me which apple you are going to purchase? These three apples are very costly.
Third one.
Yeah, third one, but this one is least costly, I guess.
Quality is not.
Quality is not up to the mark to be purchased. So the problem is, when you are in the market, it depends completely on your decision which apple you want to purchase. Right? How can you purchase an apple? You just look at the outside of the apple. You are thinking that the apple quality is good. It smells nice. You can purchase it. And after looking at the price. But I want to show you that if I go for the value for money term, I guess all of you have heard about it, value for money, how can I justify that term in this context? How can you understand what apple is the best value for money? So, our goal is to find which gives the best value for money. Now, to quantify it, we need some features, right? As you have said, the quality of apple is not good. So quality, or that is maybe called as firmness, is a feature that is not quantitatively measurable, maybe. We have these features, see, price, origin, firmness, quality, smell, size and color. Okay? And we have given some importance to these features as per our choice. Okay, suppose you want to, here we have given the highest preference to the quality, right? You may change it. I have given it as per my choice. So these are some features we are using to quantify this situation. Now, what we are doing, can you see these apples? Is it visible?
Yes.
Okay. So what we have done, we have scaled these apples from 0 to 2. Okay, we have ranked these apples from 0 to 2. How? See, this apple, as you can remember, these first three apples was very costly, right? The highest price those are carrying. So we have given 0 to these three apples. Then medium price we have given 1. This apple is also maybe costly, so we have given 0. And the least costly apples, these apples we have given 2. Okay, highest preference. 0 means lowest preference, 2 means highest preference. So what is our goal? We are trying to reduce the price. That is why we have given 0 to these things. Are you understanding? Is it clear? Okay. Next thing is origin. Maybe it is very subjective. Origin means there are different types of apples. You may give any rating as per your choice. Now is firmness. We want more firm quality apples. So we are giving 2 to these apples. These are mostly fresh apples. And we are giving 0 to the rotten ones. Right? So in this way we have ranked these apples depending on some features. Okay? Now what we have done, we have multiplied this importance, that is the 20% weightage, these are the weightage or importance, so 20%, 5%, 25%, etc. with these values. Okay? And we are trying to find out the summation of this. See, can you see this formula? This is a very named approach, importance into rank divided by 100. Okay? Now we have computed all these values. As you can see, these 3 values are the most or the highest values we are getting, right? So these values are showing us that these 3 apples are good for as per our preference. If you change these importance values, then it may change. It will change quickly. Are you getting my point? So what we have done, we have tried to accumulate all these objectives. These are objectives, right? We want to reduce price, we want to get better quality apple. We are trying to accumulate or we are trying to consolidate all these things into a single objective. Right? We are trying to increase this particular score.
So this applies for a particular buyer.
Yeah, for a particular buyer. If you change these importance values, maybe some other apples will be suitable. If you want to, maybe suppose if you increase this particular price, weightage to this price.
Importance into rank divided by.
This is a very naive approach. This is not a multi-objective optimization technique. Very naive approach. Actually, we are converting what I am trying to show you, that we are basically scalarizing the multiple objectives and we put some weights and we are trying to convert it into a single objective approach. Right? Now, if you put more weightage on price, suppose we are concerned about price, we have to purchase the least cost apple and you have given 50% here, the scenario will be drastically changed. You then see that these rotten apples will be more value for money for you. Okay? So why decision making is challenging here? Because there exists multiple conflicting objectives. Why conflicting? Because when you are increasing the price, we are getting better quality apples, right? But when you are decreasing the price, we are getting worse quality apples. Next, it is very difficult to identify good alternatives. Existence of intangibles. For example, suppose you want to measure the smell. It is very difficult, right? Smell of an apple or the satisfaction of a customer. These things are very difficult to measure quantitatively. These are some challenges. Existence of long time horizons. What does it mean? When suppose we are making some decisions today, suppose in intelligent traffic management we have deployed a model and we are trying to take decisions today depending on some past data, but it may not be the case in future. For example, suppose 15 minutes later some accidents happen. What will be the results then? We have to deviate from that particular route, right? Okay, so these are some challenges of decision making. So that is why we are going for multi-objective decision analysis. I am not interested to pronounce this particular term, Pareto optimality, at this moment. I shall come to this point later on. Okay. Do you have any idea of Pareto optimality? Any one of you?
Actual problem that you have found that there are no constraints that you have.
No, that is not constraint optimization. Yes, I have not put any constraints intentionally. I will show you the constraint version of optimization.
Customer interested in those factors, but he is carrying a bag with computing a web.
Yeah. Yeah. There are so many constraints, like you are absolutely correct. That is called constraint optimization problems. So I shall come to that later on. Any one of you, can you please enlighten us with this particular term, Pareto optimality? Okay, leave it for the time being. So what we have to understand now, that what is the meaning of two spaces. Okay, one is decision space and another one is objective space. Okay, so these are some factors that influences decision making process, like decision alternatives, underlying process, etc. Just avoiding this particular slide. Now, what is the difference between a decision maker and analyst? In the Apple example that I have given just now, suppose you are in the market, you have purchased a particular apple by your choice, you are a decision maker, right? Now, if you try to get that value for money, objective, then you may be the analyst. Okay, so we have to mathematically show someone that why you are going for this particular product or particular route. Okay. So this is the dictionary meaning of optimization. I beg your pardon, I know that many of you may know this already, but I am giving it to complete my lecture. So what is the meaning of optimization? It's an act and process or methodology of making something as entirely perfect, functional, effective as possible. So mathematical optimization is the selection of best element with regard to some criteria from set of available alternatives. What does it mean? Suppose you are in a car showroom, you have these cars in front of you, then you have to choose, like this car is less costlier than this car, but you have to think about other parameters also, right? So purchasing a car is a very popular example in mathematical optimization. Now, we all know about function, there is nothing new. So we have fx, that is x is the input, y is the output, if we write y equal to fx. Now, as I have told you earlier, that we have to understand about two spaces. One is decision space, another one is objective space. Now, what do you mean by decision space? Suppose we have 1000 values for this x, right? For example, we have 1000 values. Now, we are trying to find out for which particular value fx is maximum or minimum. Again, we have 1000 values for x. We are trying to find out for which value of x, fx is maximum or minimum. Right? So, those values of x that are possible, that are defined range, that particular set of values is called decision space, and this particular variable is called decision variable, right? Using which we are taking some decision. And this function, that is we are maximizing or minimizing, is called objective function or sometimes called cost function. Okay, so for 1000 values of x, we shall get 1000 values of fx, right?
Sir, this function, it is very, it is known, completely known.
Completely known.
It can be an approximate function or it can be completely known. If it is completely known, then it is a hard computing problem.
Yes.
If it is not known properly, there will be a font that will be acceptable solution. Font will be generated by the Pareto.
Yes.
That is actually targeted to the soft computing problem.
Yeah, exactly. Actually, if we know this function completely, that is hard computing problem as you have said, but the problem is sometimes we know the solution, but it is very difficult to compute the result in a particular time span. For example, I don't know, I guess many of you have heard about the traveling salesman problem. A salesman starts from a particular city and then he has to sell something in different cities and he has to get back in the evening to his home, right, to his home city. So if you take 20 to 30 cities, the running time of that particular problem in modern computers, I am not concerned about quantum computation or supercomputers, but if you run those particular problem in brute force method in our modern day computers, 20 to 30 seconds, it will take almost 700 hours. And if you increase it by maybe 31, 32 cities, then it will take years to solve a particular problem by your computers. So,
NP completeness.
yeah, those are NP. I do not want to introduce those terms, NP hard or NP complete problems, but these problems are
Solutions are locally accessible. Local, the software, the solution that tries to obtain are locally viable solutions.
not locally, not necessarily always locally. It can give you the global solutions also, but it cannot ensure you that always you will get the optimal result. It will give you a near optimal result within a stipulated amount of time. That is the motto of this kind of approaches. So may not be always possible to compute although those problems are practically solvable. These kind of problems are termed as intractable problems. Solvable problems, but not computationally achievable in a reasonable amount of time. So, suppose we are plotting that particular function. So, see, we are having price and maybe we have expected revenue, and we are getting something like this. Now, what is our goal? We are trying to increase the revenue or maximize the revenue. Right? So, this particular point is called local maxima. This particular point is called global maxima, and this particular point is called local minima. Okay? Why local? You can understand that this particular point is maximum compared to its surroundings, but this particular point is maximum compared to the overall graph. Right? So this is in this particular picture, what we have done, we have two decision variables. One thing I am trying to explain it clearly, that when you are having a function with something like f bracket inside bracket x and y, that doesn't mean it is an optimization function. Multi-objective optimization function. When you are having more than one variables inside your function, that is multiple decision variables, not multiple objectives, right? So in this case, we have plotted two decision variables here and one objective here. So this point is the optimal point, as you can see. Yeah, suppose we are having or dealing with a function like f inside bracket xyz. Those xyz's are the decision variables, not objectives, right? So when we are increasing the decision variables, that's not a problem. That is a single objective problem. We are just dealing with more than one decision variables. But when we have multiple functions, those are the objective functions, right? Again, one thing I must clear here also. When you are getting multiple functions, may not be those are always objective functions. They may be constraints. Okay, just some time before SAS is saying that the constraint form of a optimization function, I am showing it in some time. So mathematical optimization can be divided into two ways, discrete and continuous. So this is a constraint form. What is this? See, we have fx. So we have one decision variable, we have one objective function. It is clear, I guess. So one objective, one decision variable. What is STG? ST means subject to. Okay, don't get confused. I beg your pardon. I should put a space here. So ST means subject to. Gx is a function that is defining a particular constraint. Right? Again, hx should be 0, and this is the range of this x. Is it clear to all of you? You can please interrupt me.
HX means here?
HX is another function. There may be a lot of functions. Those are defining some constraints.
HX is related to heuristic.
No, I'm not trying to mean it heuristic. H can be anything, any function. That must be 0. Suppose you have found a solution of x for which maybe f is minimum, fx is minimum, but hx is not 0. That solution is not acceptable. That is the constraint.
Equality constraint and non-equality.
Yeah, this is the non-equality constraint, this is the equality constraint.
Can you show us an example where we are having multiple decision variable, but still it is not multi-objective and vice versa?
Yeah, I am trying to show that. Okay, suppose in a factory, let me take another example as I have said. So, suppose we have a factory, production factory, and we are producing two types of products. Okay, and now the factory has limited resources such as time and materials and must decide how much of each product to produce in order to maximize its profit. Now, let X be the number of units of product A produced. Okay, and Y be the number of units of product B produced. So X and Y are the number of units of those two products. Now the profit per unit of product A is $50 and the profit per unit product B is $40. Okay, so these two things are related to A and B. Now the total profit, how can we compute? $50 per product, so 50x and 40y simple. Okay. Now, what are the constraints here? Time constraint. The factory has 100 hours available to produce both products. It takes 2 hours to produce 1 unit of product A and 3 hours to produce 1 unit of product B. So this is first constraint that we have to satisfy. Are you getting the meaning of constraints? Suppose we have 100 hours available and it takes 2 hours to produce 1 unit of product A. So we have 2x.
What were X and Y?
X and Y are the quantities of product A and B.
Right. So the constant that we are setting, that is from some other area. It has no relation with the original function definition. I mean, the variable, it is not.
Yeah, it is not related with the original function. We have to maximize the profit. That is our goal.
Can the variable be a constraint also? One variable becoming constraint for other. Can we have that sort of case also?
One variable
Is constraint for others.
variables are itself constrained by its domain. Suppose we are dealing with some decision variables, the range of that variable is as initial constraint.
So in that case, every optimization problem is a self-constraint problem. I mean, you need not to have a constraint from somewhere else, because as you were saying that
If you are dealing with limited decision space, then if you have infinite decision space, then that is not constraint. Wow. If the range of the decision variables are limited or bounded to some region, then it is definitely constrained. And it is not that we are always dealing with a particular range. Often we deal with infinite allowable ranges. Then we have to consider a particular value that works for us, that may not be the global optima, but that is working well for our application.
But for an example, if I want to purchase a book, suppose.
Purchase
Purchase a book.
book.
Right?
Huh?
So in that case, in that optimization, will price be my variable or not?
Yeah, definitely. Price your objective. You have to optimize your price.
Okay. So the optimization factor is going to be my constraint. I mean, for an example, I have only 500 rupees. Right?
Yeah.
So that is a constraint.
Yeah.
And at the same time, I want to optimize.
Actually,
So,
I think this is a.
I can buy something which is 350 maybe, but I have that much. I cannot go beyond that.
No, so
that
actually, first you have to identify what are your variables. Your price is not a variable. As I was saying, that price is the objective. So ultimately, you want to spend minimum for your for the best satisfaction that you want to.
No, that I understand, but I am going to predict the price. But at the same time, my budget is.
Yeah, I am clarifying this point. Suppose you are in a book market and you are trying to purchase some books, right? Then suppose you are targeting to purchase 3 books. Okay. Maybe you are comfortable with 1 to 3 or 1 to 5 books, and your budget is rupees 500. So
Maybe he has got priority for certain authors.
yeah, maybe he has got offer publishers. These can be their priorities. So considering all those priorities are the decision variables, and when we are computing the overall price, that will be the objective. Now, if we have that less than 500
What that
constraint,
function returns finally. If I put all
Cost.
cost. And at the same time I have a cost constraint.
yeah, if you have fx should be less than 500, that's an inequality constraint. Definitely a constraint. We cannot go for the global optimum. We have to refrain ourselves to
itself
particular
can
range.
become constraint.
Yeah, we can put constraint from that function also. Not an issue.
So actually, sir, I think this is based on this attributes. Like price is an attribute where we can say the weights. Like
Yeah, those are this is price is the cost function. We have to optimize the cost as per the saying. Price is our cost objective function that we are trying to minimize. Okay, so if
So what are the coefficients and what are the variables? That has to be decided.
yeah, maybe the coefficients, not always, actually the coefficients that we have shown you earlier, that in that particular example we have tried to convert a multi-objective problem in a single objective problem. But that is not the case in case of multi-objective decision making always.
That is the objective function. But where from the constraints come, that is also important to understand.
But Sal is saying what is trying to Sal is saying if we can write fx there or not. We can write it. If we have some limitations.
That fx on, so gx is like fx only, but some other function.
Yeah.
So that is gx, you can think gx as fx kind of a thing. It is not truly that fx, but it is
But the problem is when you are trying to optimize, you will get the optimal outcome. Obviously, the objective of optimization is to minimize fx in this
But
case.
my optimal prediction, does it have any idea about my budget?
No, but when you are putting some constraints like if fx should be less than 500, suppose your optimization program is unable to find such value, then it will return you nothing. Putting constraints on the objective function is allowed, definitely allowed, but when it is useful, suppose your budget is 500 and you have put that constraint. Now suppose your optimization program has found out a solution with rupees 450. It may stop there.
actually the example that you are giving, that itself could be used to clarify that.
Yeah.
Because there you have x and y are variables, like weight and flavor, something like that.
Yeah, that's quite right. But there is a problem. If we put some constraint on this particular objective function, what may happen if I code it correctly, then there will be no issues. But if you write something like that if fx is less than 500, then I am good. I can purchase those books. Then what may happen? Suppose your optimization program returns the set of
X is less than 500, then it will become a constraint.
yeah, constraint. But the problem with that constraint, if you cannot code it correctly, then what may happen? Our optimization program suppose found a solution with rupees 450, but there is a solution with rupees 350. It may stop at 450 if we cannot code it correctly. That is the problem. It may not reach the global optimum.
Yes, that is.
We can put constraints like that, definitely. Even in case of infinite search space, we have to.
So in case of a linear programming gives the problem. So if we put it in a two-dimensional space, x and y is plot. So we get several lines. Those are functions, and the intersection of those lines that you get. Those are the points of the all of those are satisfied. Only few of those will be given.
The solution will reach to the global
We
optimum.
can use the concept of Pareto form.
Okay, so this is one of the constraints, and then there is another constraint called material constraints. So like that. So these are the examples of constraints, and these are the non-negativity constraints. So we can put constraints also, as you were saying, constraints also on the decision variable itself. The range of the decision variable is itself a constraint. So this is the final optimization function form. We have to maximize this one, and this is a problem with multiple decision variables and single objective. So and these are the subject these are the constraints that we have to satisfy.
So first one is like gx and the second one is like hx.
Yeah, right. And these are two other non-equality constraints. Okay. Any doubts till now? Okay. I discussed these things. So let's get back to the card example. As you can understand, we have various
One more thing,
objectives.
can you
Yeah.
go back? Can you go back? For our mathematical simplicity, can you say something like this, that it is going to be a multi-objective optimization, and in that case, we will be having multiple output from the function?
Sorry, multi-objective optimization.
So in that case, are we going to have multiple output from the function?
Multiple outputs from a single function.
Yes.
No, technically one function returns one output.
Okay.
In case of MATLAB, we can get more than one outputs, but that is not the generic case. We expect one objective particular function give you one output. And in case of multi-objective, we have different objective functions.
For an example, I want to predict a corner for some job. Right?
Corner?
It's a corner of some point. For
Okay.
a 2D or 3D or 2D block, I want to find a corner. So, and I have some certain input, suppose, and I have a function. Then in that case, suppose for a bounding box problem, right? When you are creating bounding box. So when you are creating bounding box, you need to give two set of coordinates, right? So in that case, that function, what that function is doing, it is calculating 4 outputs, right? So you can have multiple outputs.
Yes.
Function can produce multiple outputs, right? So in case of from a function view, from input output space view, can you say that if it is going to be a multi-objective optimization, can you say that we will be having multiple outputs? Can you say that?
From a particular function.
From a function perspective, because function is at the end of the day, function is going to return.
Yeah, but problem is what you are doing with those outputs, that is important. For example, suppose you have a function that is returning.
What we are doing, that comes later. But fundamentally, when I think about a function like that, in this case, it is going to give us some profit. That is a scalar value, single scalar value.
You are talking about
Right.
vectors.
Yes. So can it return a vector? And if it returns a vector, so can we say that? No, I am not saying that every time it returns a vector and that is multi-objective. But to be a multi-objective, my function, the optimization function, will return a vector or a scalar. That is my question.
If you are considering only single function and then you are trying to convert it in multi-objective optimization problem, there is 2 points. First of all, what we are doing with that vector. Suppose if you want to individually optimize the values, in a vector we have some scalar values. So if we are trying to optimize individual values, then it will be a multi-objective problem. But when we are trying to put that vector in some function and then we are getting it a single scalar value, it will be a single objective problem.
So this is an example of a single object.
Yeah, it is single object, completely single object.
Now if there is a multiple capital X, f1x, like the capital X, capital Fx, if I say f1x, f2x, f1xy, f2xy, like many other such things, it will become a multi-object.
Yeah, suppose if we have more than one function here, and Sal is saying that if this function is returning more than one value, a vector form of value, then it can be multi-objective. But if that particular vector, inside that vector, we are having some scalar values, right? So when we are trying to optimize those scalar values individually, then it will be a multi-objective problem. Otherwise, suppose we have put that vector in a function and we are getting some scalar value and then we are trying to
Actually, we
optimize.
cannot tell it as a vector because if we mention it as a vector has a modulus, has a rate. So there is an ordering based on the output itself.
Yeah, actually Sal is trying to say it's an array, basically.
Yes.
It's an array, not vector, physical vector.
Array is also a vector in sense of.
Yeah, in sense of
There are so
science.
many definitions of vector.
I understood the
Vector from
sense.
physics is different from vector in maths, vector in
Yeah,
physics is different.
yeah, I have understood the sense. Sal is saying that if that particular function is returning an array of numbers, means more than one numbers.
So if you have f1, f2 like that, it will become an array of numbers.
Yeah, if you store those numbers in a particular array, it will be an array of numbers. Sal is saying that instead of having multiple functions, if we are getting those numbers from a single function itself, can we call it multi-objective or not? If we are optimizing.
That is not my question. My question is, to be a multi-objective, is it going to produce a collection of numbers?
Yeah, definitely. We have to optimize more than one objective.
That is my question. It is. We understand that even if it returns an array or anything else, even then it could be a single objective.
Yeah.
But what is the necessary condition.
But if you are comparing the solution, suppose you have got two solutions, two arrays you have got. So because one array you have got, say one array is containing some sequence of numbers, another array is containing some sequence of numbers. You cannot compare them. If you are comparing them, then it will isn't it, sir? So solutions you cannot do vectors, you cannot compare the way. Anyway, it is not going to be vector, it is an array. Suppose it's an array.
Yeah, actually there is no need to comparison. We can find the optimal value for each of those scalars. We have to treat those scalars one as our objectives. Then it will be multi-objective.
It can be vectors also. Actually, it can be vectors. As I said at the example that I gave, if you want to find a bounding box, then it is written only a coordinate. So you return some coordinate, that is vector. Right? Every double of coordinate is vector.
And the solution and the vector, that the array value that you are saying, that those are actually points on those.
Yeah, if Sir is saying about the coordinates, if it is a coordinate, then it cannot be a multi-objective because we may not be trying to optimize individual coordinates. We may try to optimize those 3 values or 4 values maybe in n-dimensional space. We may try to optimize those values as a whole. Then it will be a single objective problem. If we are trying to optimize that particular problem in different dimensions individually, then it will be multi-objective problem.
We need a break.
We need a break. Okay.
And those solutions if we trace by some font or something, that is a Pareto.
I will show you that. Pareto front means those solutions cannot be dominated by others. Those are not, we cannot say those solutions as a best because there is no single best one. But those solutions are not dominated by others. Now, definition of domination I shall show you. What is the meaning of perfection and the meaning of domination? We shall discuss.
So we should go for GPT.
Yeah, please.